All right, hello everyone. Let's start another review session. This time we're going to go over statistics and probability. We'll go over the review sheet that we did in class, or well, we started in class. Let's go ahead and go over the answers, all right? So, our first question. Sophie spins a fair four-sided spinner. I do want to go ahead and point out this word fair. So we have the word fair, which means that every chance is likely, or sorry, every outcome is equally likely. They all have the same probability. We could have biased, that is the opposite, where things may not have the equal probability. Here, the things are fair, so everything on this spinner here is going to have the same probability of happening. So, looking at the question here, on the probability scale, we need to mark with a cross x the probability the spinner lands on a 2. So we see how many sides we've got on our spinner. We have 4. How many of them are 2? We've got 2. So our probability is 2/4, which when we simplify this is 1/2. And on our probability scale from 0 to 1, 1/2 is in the middle. So right here at 1/2 we put an x. And we're done. For part B, write down the probability that the spinner lands on 4. I don't see a 4 anywhere on here, do you? There's no 4. So since there's no 4, that means it is impossible. There is a 0 out of 4 chance of that happening. You could say this is just 0, or you could even say 0%. All right? However you look at this, it's not going to happen. Moving on down to the next one. An ordinary fair dice is thrown once. So again, fair, that means that all sides of the dice are equally likely in happening. Let's make this a bit smaller. And remember, an ordinary dice, that means it's going to have 6 sides. All right? I like it better, a little bit thicker. Okay, so on the probability scale, mark with a cross the probability that the dice lands on an even number. So remember, on our dice, we've got 6 numbers, 1, 2, 3, 4, 5, and 6. And out of all of them, how many even numbers have we got? We've got 1, 2, 3. 2, 4, and 6 are our even numbers. So we have 3 even numbers out of 6. So again, a probability that lands on an even number is 3, 6, which we simplify is 1/2. So we've got a cross in the exact same spots. Here, though, we want to write down the probability that the dice lands on a number less than 3. How many numbers do we have that are less than 3? Well, we've got 2 numbers here. So we have 2 out of 6, which we will simplify as 1/3. Okay, so 1/3 we could leave as a fraction. I suggest leaving these as a fraction if you can. You could also write these, however, as a decimal or as a percentage. 1/3 won't be so nice. It would be 0.3 repeating or 33.333% repeated. All right, anyway, let's move on. Let's not waste time. There are red counters, blue counters, yellow counters, and green counters in a bag. A counter is picked at random from a bag. So again, random means that we have no control over the outcome. The table shows the probabilities that the counter will be red, will be blue, and will be yellow. We need to complete the table to show the probability that the counter will be green. So this looks like it was an experiment, or maybe there are more or less red and blue of different colors in there. However, we should know that whenever we have probability, all of our probabilities of a certain given event should add up to 1. So whatever we're missing, in other words here, the probability of it being green, that plus the probability of it not being green should always add up to 1. So what is the probability of it not being green? So here, if we add all these up, 0.2 plus 0.4 is 0.6, 0.6 plus 0.3 is 0.9, and so if we take 1 minus 0.9, we are going to get 0.1. So the missing probability here is 0.1. There's a 0.1 probability that the counter will be green. We could say that this will be 10% or 1/10. However, since it's written as a decimal, we're going to leave it in decimal form. Moving on to the next one. The two-way table gives information about how 100 students travel to school. So in total, they are surveying, or they're asking 100 students. So that's where our total of totals is going to be. And they've broken this down into 2 ways. So they have up here the modes of transportation: walking, car, and other. And they've broken this down by gender, by boys and girls. Unfortunately, they are still in the last century where we only have 2 genders. Anyway, moving on. So we need to figure out, first of all, what is missing here. Part A is to complete the two-way table. So If I see that there are 100 students in total, and that they have 52 boys here, right? This would mean there are 52 boys. How many girls are there in total? We simply take 100 minus 52, which is going to give us 48. And now, essentially what we're going to be doing is we're just going to fill in these rows and columns that are missing one square or one cell. So I can see here, for example, right, I can see that this total is 19. So I need something plus 8, which will give me 19. Or in other words, 19 minus 8 will give me what's left here. That would give me 11. Now I can see that I've got a total here of 52, and I've got 15 plus something plus 11, which will give me 52. Well, that must be what? So 15 plus 11 is 26. 52 minus 26 is actually 26 again. All right, now I'm missing a total here. So I've got 26 boys who go by car and 22 girls who go by car. So 26 plus 22 is going to give me, you got it, 48. Okay, and then here, what total have I got? So I've got 48 minus 8, which is 40. 40 minus 22 is 18. So that must mean that 15 plus 18 is going to give me 33. And if I do check my math, 33 plus 48 plus 19 should in fact give me 100. So we have correctly filled in our table. Next, what I need to do is I need to solve this problem. So one of the students is picked at random. We have no idea who it's going to be, just a random student. We want to write down the probability that they walk to school. So this isn't boy or this isn't girl, it's that any student in general if they walk to school. So I look at the total students who walk to school, which is 33, out of the total students surveyed, which is 100. Done. The probability they walk to school is 33 out of 100. You could, of course, write this as a decimal. You could also write this as a percentage. Please keep in mind, this is 33 out of 100. This is 33%. This is not 33.33333 forever. You cannot simplify this to 1/3, technically, okay? It is extremely close to 1/3, but just ever so slightly smaller. Let's move on to the next page. All right, so we've got another two-way table. A football team played 38 games. So we already have an important piece of information. They played 38 games in total. So let's go ahead and fill that in our table. So 38 games. So we got games at home, games away, games they won, they drew, and they lost. So we have 19 games were played at home, and the rest were played away. So home games, there were 19 of them, and the rest of them were played away. So 19 plus what equals 38? Well, that's also going to be 19. So let's see. The team won a total of 21 games. So we go over to 1. The total, they give us literally the words there, 21. They drew 4 games away. So we go to drawn. And away we're going to put 4. And then 2 of the 10 games they lost were at home. This is a bit tricky one. So they're saying that they lost 10 games in total, and 2 of those were at home. So here we're going to put 2 for lost at home, and 10 in total. So we can already start to fill in what's missing here, right? We can see, so they lost 10 games in total. 2 of them were lost at home, so that means that they must have lost 8 away, right? 10 minus 2 gives us 8. Okay, we can start to fill in some others now. In fact, we can pretty much fill in almost all of these. So let's go ahead and fill in our total here. So our total of total games is 38. They lost 10, so 38 minus 10 is 28. 28 minus 21 is going to give us 7. Okay, so if they drew 7 games in total, 4 of them away, we take 7 minus 4, that's going to give us 3. And now we just need to see, okay, what plus 3 plus 2 gives us 19? So 19 minus 2 is 17, minus 3 is 14. And we can do this either from the row or from the column. Let's do it for the column. 21 minus 14 is going to give us 7, and just to double check, 7 plus 4 is 11, plus 8 gives us 19. So it all adds up. We've done it correctly, and we are done and moving on to the next. Okay, next problem. The probability that a sunflower seed will germinate is 0.9. So in other words, how likely is it that a sunflower is going to grow? About 0.9. Alan is going to plant 50 sunflower seeds, so we want to work out an estimate, in other words, a guess, for the number of seeds that will germinate. And the way that we do this is we're going to take our probability and simply multiply it by our frequency. So we're going to take 0.9 times 50, which is going to give us 45. This is a safe estimate, so we are done. We can move on to the next. Okay, I remember I mentioned this word biased earlier, right? What does biased mean? Hopefully you remember. It means that it is not fair. One outcome could and most likely will happen more often than others. So this is going to be a biased spinner that can land on red, blue, yellow, and green. The table shows the probabilities that the spinner will land on red and yellow. So here red is 0.18, yellow is 0.26. The probability of landing on blue is the same as the probability of landing on green. So in other words, these two numbers should be the same. So we need to complete the table to show these probabilities. Okay, so we know that if we add all of these together, it should equal 1. So if I take red plus yellow, 0.18 plus 0.26, that is going to give me 0.44. And so now I know that whatever I have left, I need to divide evenly among these two, so I'll take 1 minus 0.44, which equals 0.56. And I'm just going to divide that by 2. 0.56 divided by 2 is going to give me 0.28. So I should have 0.28 and 0.28. That's a 5, not an 8. I don't know why I wrote that. And if I want to check my math, I could do that, right? 0.28, again with the 5s, okay, times 2. I do get 0.56, and then plus 0.26 plus 0.18, and I get 1. So we can see that this did work out. Perfect. Okay, let's move on to the next. Okay, in a bag, there are only red counters, blue counters, and white counters. A counter is taken at random from the bag, and the table shows the probability of getting a red counter. The probability of getting a blue counter is the same as the probability of getting a white counter. So again, the exact same style of problem for at least for part A. We need to complete the table. So if red is 0.2, we know that in total, red plus blue plus white is 1. So we'll take 1 minus 0.2, which is 0.8. And we will take that and divide by 2 to get 0.4. And that will give us our probability for both of these. Okay, so if we know that there are 18 red counters in the bag, we want to work out the total number of counters in the bag. So we can do this a few ways. For me, the easiest way to see is that, okay, if I see that 0.2 represents 18, I know that this is going to be double, so I can take 18 times 2, which gives me 36 blue, and that means I'm also going to get 36 white. So if I take my 18 red plus 36 blue plus 36 white, this is going to give me 90 in total. So there should be 90 counters in the bag. All right, this next one. This one's going to take a little bit more work, and it's probably going to be a bit easier if we have a calculator, but let's go ahead and work it out. Okay, so the table below gives us information about the time taken for 20 people to run 5 kilometers. So 3 ran it between 15 and 20, 6 from 20 to 25, 7 from 25 to 30, and 4 from 30 to 40. Okay, important to note, this interval is slightly different from the rest, okay? Don't just go assuming they're always the same, because they aren't always the same. So first, we need to find the class interval, in other words, find which of these, which group, contains the median. The way we find a median from the table, so how many do we have in total? It tells us we have 20 in total. So if I line up all these numbers in a row, all 20 numbers, I'm going to look for the ones exactly in the middle. If they're an even number, it's going to be 2 numbers, right? Because there's not going to be just 1 in the middle. If it's odd, there will be exactly 1. Here we have 20, that means there's going to be 2 in the middle. So the way we find that, let's erase this. So the way we find that, we take our amount divided by 2. This gives us 10. So we're going to be looking for the 10th number in order, and the one after it, the 11th. Okay, so the first 3 numbers I know are between 10, 15, and 20. So I got 1, 2, 3. The next 6 numbers are from 20 to 25. So 4, 5, 6, 7, 8, 9. Okay, so the first 9 numbers are between 15 and 25. So number 10 and number 11 are going to be in here. So this is going to be where my median is at, because the 10th and 11th numbers are here. In fact, my 10th number to my 16th number will be in here. My 17th to my 20th number would be here. All right, so next we need to work out an estimate for the mean. So to find the mean of these, first, what we need to do is find the midpoint, or in other words, what number is in the middle here. Let me erase I call this my cumulative frequency, adding up as I go along. I'm just going to look at my normal frequency now. So I'm going to take my midpoint. The number between 15 and 20 is 17.5. Here, 22.5. Here, 27.5. And here, between 30 and 40, just 35. So now what I'm going to do, I'm actually going to take these and multiply them all. This is going to be helpful if you can use a calculator. So just plugging these in really quick. So I've got 3 times 17.5. Actually, let me go ahead and show you a good way to do this on a calculator. So let's go ahead and use brackets, okay? So we're going to do 3 times 17.5 in brackets. Then we're going to add that to, we're going to save ourselves some time here, 6 times 22.5. Oh, I didn't put my brackets in. That's not good. Let's go back. Oh, it doesn't want to let me go back now. Okay, that's a bummer. Okay, well, all right, so I'll do this the old-fashioned way then. 3 times 17.5. That gives us 52.5. Okay, next. 22.5 times 6. It's going to give me 135. Next, I've got 27.5 times 7. It's going to give me 192.5. And finally, I've got 4 times 35. Which gives me 140. So now what I'm going to do, if you don't remember, when you're finding the mean from a frequency table, if something is mean to you like this, you get mad. In other words, you multiply, then you add, and then you divide. So we're going to take all these numbers and add them up. We're also going to add to get our total frequency if we don't already know it. Here we actually do already know it, but still we'll pretend we don't. So we add all these together. So we're going to take 140 plus 192.5. Okay, well, it forgot 140 for some reason. Plus 135 plus, no, plus 52.5. And we're going to divide that by what our total frequency is here, which is 20. So we're going to take this answer, oops, no, not like that, 520 divided by 20, which gives us 26. So our estimate for the mean would be 26 minutes. Okay, that took quite a bit of time. These questions do unfortunately take a bit of time. Whenever you're putting them on the calculator, it may help you to go ahead and use brackets and add as you are multiplying all together. This may save you a bit of time. However, you could also work this out and write this down. In fact, that's actually what I highly recommend that you do on exams, so that way I can see your thought process, and wherever it is you may make mistakes, I at least see where the mistakes are. I can see that you have followed the process, and I may be able to award you some points for following the process and not just getting a wrong answer in case you do get a wrong answer, okay? Always show your work, even if you use a calculator. Okay, so moving on, we're going to do the same thing now, but we're going to use slightly harder numbers. Okay, so Adam is measuring his tomato plants. Oh, how cute. All right, so we're going to do the same thing here. We're going to find the midpoints. So the midpoint of here, right, we're finding the mean height, and it looks like we're going to have a nasty decimal, so we're going to round it to 1 decimal place. So the midpoint here, between 140 and 150 is 145. From 150 to 160 is 155. From 160 to 170 is 165. 170 to 180 is 175. Be careful, they like to trick you. 180 to 200, much bigger interval now. Why did I put 8? That's a 5. Is going to be 190. So again, they ask for the mean, so we get mad. We multiply, we add, and we divide. Let's go ahead and add this up first because we're going to be using this in just a little bit, okay? So let's move our calculator over to this side now. if it will be so kind. Let's clear everything. So we've got 7 plus 10 plus 15 plus 19 plus 9. So in total, it looks like Adam has got 60 tomato plants. That's a nice garden. All right, and now, actually, we're not going to add all those. We're going to multiply them all first, and then we are going to add. So first, we take 7 times 145, which gives us 1,015. You can already see why it's going to be nice to have a calculator for a problem like this. We have 10 times 155, even though we actually don't need a calculator for that one. That's just going to be 1,550. 15 times 165. It's going to give us 2,475. Next, we got 19 times 175. So we get 3,325. And finally, we have 9 times 190. 1,070. Oops, sorry, 1,710. My goodness, be careful. All right, so next we're going to add all these up. So we have 1,710 plus 3,325 plus 2,475 plus 1,550 plus 1,015. And that gives us 1, 2, 3, 4, 5 numbers with a total of 10,075, which we now need to divide. So mad, right? Multiply, add, and divide. So we're going to divide by 60. Divide this by 60. And we get 167.9166666666. Okay, so whenever we're going to round this now, we'll see. So we got 167.916. It's asking us to round to 1 decimal place. So we're going to have 167 point. If we take a look here, this is going to be where our decimal place ends. So we need to look at the one after this, which is just a 1. It's clearly less than 5. So we're going to round down and leave this at 9. So our answer should be 167.9 centimeters. That'll be our final answer as an estimate to our mean. Moving on to the next. Mark ran a mean distance of 132 kilometers in 5 days. So we don't know how much he ran exactly, but we do know that if we add it all up and divide it out, we would get 13.2. One way to actually kind of think of this is that imagine if he actually did run the exact same distance every single day, the mean would be the exact same. So we're just going to pretend that works because for all we know, he didn't, but he could have. And either way, it doesn't really matter. Whenever we take the mean, we essentially take more away from the bigger and give it to the smaller. It's a very, very it's a very communist point of view, right? Everybody should get the same amount. So here we're going to take 13.2, imagine for these 5 days. But the next day, Mark runs 20 kilometers. So we're going to add 20 to this. And now we need to find the mean distance for the 6 days. So we're going to take all this now and just divide by 6. So using our calculator, just to speed things up a bit, we're going to take 13.2 times 5, which is 66. We're going to add 20 to this, which gives us 86. And we're finally going to divide by 6, which gives us 14.3. 14.3 repeating. So the mean here is going to be 14.3 bar. You could also call this 14 1/3. Don't forget your units. We're measuring here in kilometers, so we're going to measure it in kilometers. Okay, done. Moving on to the next one. Oh, we're halfway done. We're doing great. Okay, so here we need to draw a frequency polygon. A frequency polygon is essentially a fancy number line. The only difference, it doesn't give us exact points at first. We need to find midpoints. So here, if we want, let's go ahead and just do this for fun. We'll find the midpoints of our gaps here, 15 to 20. It's going to be 17.5, 20 to 25 is going to be 22.5. I'm not going to find the other ones, and I'm going to show you why in just a minute. So what we do for this, we're going to take this information. So the 17.5 is going to be for our time, somewhere in here. So we're going to go to 17.5, and we're going to follow this up to whatever our frequency is. We're going to follow this up to 3 and put a point. Next, we're going to do that, so 22.5. So here, 22.5, and we're going to go to the frequency, 6. So 22.5, 6, put a point. Now, I didn't do this for the other two. What do I do? Well, you see it's going to be exactly halfway between. I think most of us should be confident enough in eyeballing where it's halfway between our intervals, right? Especially when they're so nice and clearly marked for us exactly like they are on the table. So halfway between 25 and 30 is this line here. We follow this up to 7, put a point. Right, this would be 7. And finally, 30 to 35 in the middle, we're going to go up to 4 and put a point. We cannot leave this like this. We do have to connect these lines. So ideally using some kind of ruler or some kind of straight edge, you will connect them. Using that as a major paint on here, which is going to take way longer than it should, so I'm not going to do that. But here we get an idea of what it's going to look like. Okay, keep in mind, you do not need to extend this here. And you should not draw any line connecting this to 0 or anything. You should start from your first point and end with your last point, and that's it. Okay, so we're going to look at a different frequency diagram. We're going to be looking at something called a histogram next. So we're going to use the information on the table to complete the histogram and use the histogram to complete the table, right? So they're giving us a bit of information in both sides. We just need to fill it in. All right, so let's see what it tells us on a histogram compared to the table. So you got 10 to 25, 25 to 35, 35 to 40, 40 to 45, and 45 to 60. Okay, so 35 to 40, that's going to be here, right? It says it goes up to 42. So whatever this is 42. So that must mean this is going to be like 10, 20, 30, and 40, right? So it goes up to here, 42. Okay, so that must mean that this here, 40 to 45, this must be at 30. Okay, so excellent, great. Now, let's go ahead and fill this in for the rest of ours. So we already have our my goodness, our ranges, right? So from the first one, 10 to 25 is going to be at 12. So go up to 12. We're going to draw this over to 25. And again, ideally, you should fill this in. Okay, from 25 to 30, it's going to be at 28. So right around here. I can't believe I'm actually drawing this somewhat accurately with a tablet. Okay, 35 to 40, 45 to 35 to 40, 40 to 45 are already done for us. So now we need 45 to 60, which is going to be at 9. So just one under this slightly darker line here. And that's it, we've got it filled in. All right, so moving on to the last page. We've got something here. We went through these fairly quickly, but these are very common, especially on exams. So this is a scatter plot or a scatter graph. So this gives a bunch of different exact data, and you can use this to make some kind of, you can see if there is something called a correlation. So here you can see, if I were to try to connect this, right, there'd be almost some kind of line that these would go through, right? Where you try to get the same, more or less the same number of crosses or points on both sides of the line. Mine's probably just going a little bit low. I'd probably want to draw it actually a little bit higher. It'll probably increase my slope just a tiny bit. But this is a very close, what we call line of fit. All right, so this shows scores of 16 students on their biology and physics tests. And so we're trying to see if there's a relationship between how well these students do in biology versus how well they do in physics. And as you can see, if they do poorly in biology, they also do poorly in physics, right? This student got, looks like a 26 in biology and a 25 on, or sorry, that looks like a 32 on biology and a 30 in physics. They did pretty poorly. And as we keep going up with biology, We also seem to be going up with physics for the most part, right? There are a couple exceptions, but again, they all follow a relatively close pattern. As one score goes up, the other score also goes up. So we can see that there is a correlation, and this is what we're going to call a positive correlation. If both go up at the same time, we called it positive. If we had one going up but the other going down, we would call this a negative correlation. And if you have a graph where you just have a bunch of random or seemingly random points, you can say that there is no correlation, okay? Just as a quick refresher. Okay, so another student scored 52 marks on their biology test. Let's estimate the physics score for this student. So if I have some kind of line of best fits, we're going to go ahead and say that this is my line of best fit. So we're going to go ahead and find 52 marks on their biology. So we go over, find 52, so there's 40, that's 50, that's 52. So we're going to follow this all the way up to right about where this line is. And as you can see, this intersects my line. If I had drawn it a little bit higher like I initially wanted, it'd be somewhere around there. We're going to say this is going to be somewhere around 60. If you said that this was around 62, that would also work, okay? So essentially what you're trying to do is find, so one score, see where it touches your line of best fit, and then figure out where exactly that meets on the other score. Okay, just a couple more and we're done. 3 more to be exact. So here we have a stem and leaf diagram, just a one-sided stem and leaf diagram. We want to work out the range and the median age from this table. We see that 1 bar 7 means 17, so we have 17, 19, and so on. So the range, we're going to look for the smallest number, which is 17, and the largest number, which appears to be 33. So we'll take 33 minus 17, which is going to give us 16. So the range is 16. We're already done. Cool. Now, how can we find the median? We can either count how many they are and find it just like we would with the table, or we can do what we did if we had a big list and just cross. So cross off the 2 extreme ends. So biggest and smallest, new biggest, new 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 smallest, and we have these 2 left in the middle. So that means that we have a 25 and a 27 in the middle. If you need to find what's between them, you can simply add them and divide by 2, which will give you 26. So the median age is going to be 26. Okay, now we've read and found data from a stem and leaf diagram. We need to draw our own. Okay, and we must include a key. So here we have speeds of 20 different cars. We see that our lowest is going to be 40 something, right? So let's go ahead, let's draw our bar. It's going to be 40 something, and our largest, we have 50, we have 70. I don't see any number bigger than 70. I do see 50s and I do see 60s. So we're going to go ahead and draw it there. We don't have to draw 0, 1, 2, 3 if we don't want. We can actually start from 4. So we're going to do that. So going through now, where are all my 40s? So I've got 43, 49, 48, 45, 42, 47, 47. Okay, so the smallest of these is 42. Then I've got 43. Next I've got 45. Then I've got 2 47s. I've got a 48 and then a 49. I'm going to change colors just to keep track of this. So now for my 50s, I've got 55, 58, 51, 52, 50, and 58. So I've got a 50, I've got a 51, I've got a 52. What have I got left? I've got a 55, 58, and 58. So 5, 8, 8. And my 50s are done. Next, I've got 60s. Let's do this in red now. So I've got 67, 69, 63, 65, 64, 63. So my lowest is going to be 63, and I've got 2 of those. So we've got 63, 63. Next is 64, 65, 67, 69, 79, and finally I've got 1 lonely 70. And so my table is almost done. I just need to include my key. Very often, we often just take whatever our first value is, and use that as our key. So let's say 4 bar 2 equals 42. We'll even label this as a nice key, and we're done. And we're finally down to our last problem. This table shows some information about the favorite television channel of some people. So we got some missing frequencies and we got some missing angles. Here I asked you not to worry about drawing this, so we're just going to fill in the angles and we're going to be done with it. All right, so how do we do this now? In total, remember in a pie chart, I'm going to have 360 degrees. I see that there are 720 people in total, so I can see that whatever my degrees are, if I double that, I'm going to get my frequency. So 90 times 2 is going to give me 180. And to solve this over here, I haven't done this ahead of time, so I'm going to use my calculator. Although this one wouldn't be too bad to do by hand. 720 minus 228 minus 144 minus 180 will give me 168. And now I really just need to divide all these by 2 to get the angles I need. 144 divided by 2 is going to give me 72. 168 divided by 2 is going to give me 84. And 228 divided by 2 is going to give me 114. And if I add all these up, I can double check, and I am going to just double check. 90 plus 72 plus 84 plus 114 does in fact give me 360 degrees. So when I, in theory, draw my circle with my compass, mark your center, draw a radius, and then just go along with a protractor and measure for each way. So you'd have 90, for example, that would be BBC1. Then you would go from this one and measure, for example, 72. Then you go from this one, for example, and measure 84, and then you should be able to double check, and this one would be 114. All right, so that's how you would do that if you had to. I didn't ask that you do that, so this is ideally just extra information, but that is it. That is the end of our our statistics and our probability practice. I hope this has been useful, and if you have any questions, as always, please just send me a message or talk to me in class. Good luck studying, guys.